but now everything is okay. No, this is the normal recording. There is something new, but I will not, I have not done this, and I have no, oh, that's a pity. Oh, that's a pity. Okay, at least I try. So the problem was that I could not record what is on the table. Oh, you cannot see my screen. That's a problem. Why don't you tell me? So now, you can see my screen. Just I don't show what I want. Okay, just a test. It's not good. I have something, a frame, just I didn't put it in. Okay, no, there is no recording today, doesn't matter. I will not write on the table. So, everything will be uploaded to the Teams. And do you see the Teams group? Yes. I prefer Moodle, but no one used it in the last semester. So I prefer use the Teams. Perhaps I will upload everything to YouTube too, because that's a portfolio for me. Okay, so my name is Gábor Facskó, you know very well. I'm a so-called senior research fellow. Do you know what does it mean? Here there are different levels of professors. The first, there are, on the bottom are the so-called engineers of the department or research engineers. In French, engineer de chercher. They are engineers. The Zara is an engineer. She doesn't have MSc, just only BSc. Then the PhD students, it has a name in the old days, but we don't use it. If you have PhD, you could be assistant professor, then associate professor, full professor, and the full professor is in theory on the top. But in Hungary, if you are a member of the Hungarian Academy of Sciences, then you are the god. And sorry for the sarcasm. Actually, we have a very difficult system. You need PhD, then a Doctor of Science. It's necessary to be a full professor. And then from the Doctor of Sciences, you can elect 365 immortal, the member of the Hungarian Academy of Sciences. When there are corresponding member, normal member, I cannot translate properly, they got some extra money from the academy, and they usually manager of the institutes. That makes things very, very difficult, actually, but I am not in this rank, because I am a scientist, and in the scientist you have research assistant, that's the PhD student, research associate, that's the postdoc, then there is senior research, then research assistant or associate or research fellow, and I was research fellow, always independent, and then senior research fellow is follow-ups. And then there is a so-called, what is the name? Senior research, scientific advisor, and and finally there are research professors. And what does it mean? If you have PhD, then you are research fellow or research associate. You do not need so-called habilitation that's necessary for being associate professor in Hungary, for being a research fellow, senior research fellow. That's why I'm a senior research fellow. And then you need a Doctor of Science. It's a special qualification given by the Hungarian Academy of Sciences to be a scientific advisor. It's equivalent to the full professor, and then the guards, the members of the Hungarian Academy of Sciences, are the research professors. That's very disturbing, and also disturbing. I'm a senior research fellow here. I will do a habilitation and I will be an associate professor very soon. This is my task for this semester. This is my homework. I have two workplaces. This is the University of Pecs, Faculty of Science, Institute of Mathematics and Informatics. And I also work in the Wigner Research Center for Physics, that you cannot read actually because of the sun and because of the size of all of the letters. Okay, and well, in the last semester I have two full-time jobs because I'm very well paid, and now since 1st of February I'm in 10% at Wigner, so I am mostly here. I have a homepage, you can visit it. This slide will be uploaded to the Teams. Okay, then course objectives. I also uploaded the syllabus, the aim of this subject, these terms and basic methods, blah blah blah. So the first 6 lines is from the syllabus. Well, there is a good English term called bullshit. This is nothing. What I will do, the linear algebra is a good tool. It's a good weapon. It's necessary to understand quantum mechanics. It's necessary to understand informatics, different image processing or signal processing, and it's very useful in many ways. So that's why all engineers or informatics or chemists and physics students learns it. The first version is this elementary linear algebra is quite simple because some reason. For example, you have human rights. We didn't. I was a physicist in post-Soviet countries, like here in my time. There was no BSc, MSc, just everything was together, and the teachers and the researchers, scientists were separated. And we were like a horse. So the linear algebra was 5 + 4 hours per week, with a test every week, every first day. That was my class. So everything that you learn and more, calculus, I learned together in the first semester. So this is divided, and the IT students don't study advanced, applied linear algebra. Okay. I have told you I will follow the thematics, but I will give you more. Everything will be uploaded to the Teams. There is only one Teams group right now because you are in the practice. Everyone is the same. I checked actually. There are some guys who there is this exam course, so they signed for that one. I added them manually. Okay, great. Next one. You will write 2 tests. And you have to pass. For passing, you have to write 41% of both tests. If anything is wrong, then you can correct the test. What will happen on the first week of the exam period? You can write this again. Not only one, but both if you want. I will book a room for 3 hours or 4 hours, and you can do it. For my test, you can use everything, whatever you want. If you're not prepared, it will not help. I have good examples for this. Actually, it was a Unix class. It was really funny. At Milton, someone used ChatGPT to write the test. Okay, great. but he didn't check how to install Linux. He thought that ChatGPT will do it. It didn't. If you write a code or if you calculate, this linear algebra is very close to coding actually. Then if you don't practice the methods, you will not pass. But if you prepared then for the test, then it helps if you do not need to memorize some things. Okay, this time there is no offered grade because you are not 130, just 5. So you will have a written exam. In the syllabus there is oral exam. I prefer written exam. Then I will give you theoretical questions and very simple, quite simple exercises that you can solve if you know the theory. There will be 3 times for this in the what is the name in the examination period. This time perhaps I will be able to discuss with you when it could be. As soon as possible, because there is no AC, no air condition, and from May it will be very hot. Or not, but usually it's hot in Hungary. Okay, bibliography. There are some suggested books. Well, I look for them, and 2 of them, I think the last 2 I find on the internet free. I uploaded to the Teams in the book or books directory. The Hungarian, this afternoon I will have a class with Hungarians, the same, everything, for the same students. I mean the same physics and chemistry students. So in that I find more, okay, so the syllabus is different for English and for Hungarian students. I don't know why. And also the bibliography, the suggested books are also different. I don't know why. But one of them is enough to cover almost everything. So what was in English, I uploaded to your Teams directory too. So if you do not understand anything, then it's okay. Some of them is a link. And on MIT or on somewhere, the link is not only for the book, but for the course, with slides, with video recordings, everything. That's great, actually. But I hope you will come and you will learn everything from me. Okay. So I told you the requirements. Some other things. Yes. Okay, so this first thing is first lesson. This class is just repeat of the last term, but it's faster. So, what's this? Scalars and vectors. So the vector is nothing more than quantities with direction. It could be position, it could be velocity, acceleration, weight, or something like this. You can use this boldface, this underline, or the arrow sign, which is easier. You can use whatever you want. Okay. No, that's too much. Other graphical definition. You have 2 points, A and B, and you have a limited length line segment, and a direction from A to B. That's a vector. two vectors are equal if you can transform the first vector to the second vector with parallel shift. Or it means the length and the direction are the same. And it forms a group. If the group is all vectors that you can shift to parallel translation, parallel shift or translation displacement to each other. That's a group. You don't need to know too much about. Yes, here we will talk about two-dimensional and three-dimensional vectors. That's it. Okay, question. Coordinate systems. What coordinate system do you know? I mean, in last semester or from chemistry or physics or anything.
Well, the coordinate systems, they can have, firstly, they can have a different number of dimensions, like two-dimensional, three-dimensional, everything.
Yes.
And also they can be like planar, or they can be like a polysphere or other shapes.
So you know Cartesian? Cartesian? Do you know polar coordinate system? Polar coordinate system? Do you know it? You don't know polar coordinate system? Oh, I cannot write. Oh. So the normal coordinate system, you give this in this way. But you have another way. You take this direction and then this length. And then this is equivalent if you don't give the x, and y, just give the r and the t, then it's equivalent. It's very simple. Okay? You never seen this?
No, I've seen.
You have seen?
Yes.
Polar coordinate system. And in three dimension? No, never? Well, you're standing on the earth. You can give the altitude, you can you can give the latitude and the longitude. That's also a three-dimensional polar coordinate system. You heard about you heard or not? You heard?
Yes.
Okay, but you are in your second year. You heard here or before you came here?
I heard in high school, I think.
High school. Okay, that's very interesting. There was one Turkish girl in the class who had lectures in the high school that was almost university level. Okay, so this is one polar coordinate system. In 3 dimension, it's more difficult. Actually, not difficult. Difficult to me to draw it. Then, do you know the criteria of the wrong lectures? There are 3 criteria, conditions.
And the what?
Wrong lectures. First, you draw a formula on the blackboard and do not explain it. Second, you are standing to cover it, and then you erase everything and you cannot write it. So I try not to do this, but because of my dimensions, it's often happened. Sorry. We have this and now this is just a normal 3-dimensional coordinate system, but if you use R and I have to erase, otherwise I cannot. No. Something is wrong. No, not. Here you have a direction, one angle, and then other angle, and these are equivalent. But to calculate, do the transformation is a bit more difficult. That's the simplest. This is here. However, the others are and then wait, no. Sorry. This is it. And then okay. So this is in 3 dimension the polar coordinate system. Do you know which one? You know it? You? Okay. Then, one thing, in the practice I will show you more coordinate systems. There are many, and you use the coordinate systems as you wish, as it is comfortable for you, because some calculation is much easier to do it. So if you are interested in, for example, I can show you coordinate system in space physics. But you are not physicists, but because you didn't tell me anything that I told you, then what you need, then I give you examples from my profession. Okay, so coordinate systems. Here we spend many times to do and explain the equivalence of the pairs and triplets, and also there are more coordinate systems. I don't know. Let's check something here. Just a moment. Not this one. Here. This is in Hungarian. This is your future. Okay, physics basics, physics seminars, that's great. Physical chemistry, that's okay. Okay, so there is, okay, that's something else. So here we use and deal 2 and 3 dimensional vectors, but there are more. In special relativity theory, there are, what is it? Not triplets, quadlets. So the four, it's a 4-dimensional space, 3 dimension in 3 dimension in space, 1 dimension in time. This special relativity theory was mixed with quantum mechanics, and the result is the Dirac. Do you know Dirac? Have you ever heard about Dirac? No. Do you know what is positron?
Yes.
You know? Do you like science fiction, or do you know what is positron?
I know it because it's the part of like beta degradation of the atom, the beta particles.
Yes. Okay, then from the radiation, radioactivity. It's positive beta. I don't know the term, but okay. Well, I will check it out. Do you know what is proton and electron?
Yeah.
Do you like Stanislav Lem? Invictible? No? Okay. Do you know what is antimatter? Here in our universe, protons are positive, electrons are negative. But theoretically, there could be positive protons, antiprotons, and positive electrons, positrons. If you mixed this quantum mechanics and special relativity theory, you got the Dirac equation, and the Dirac equation gives explain the existence of electron and positron. Okay, sorry. As I told you, I give you my examples from my profession. Perhaps it's too difficult. Then tell me. Doesn't matter. Okay. So there are more than 2 and 3 dimension, and there are infinity directions. This called quantum choroidynamics, and it's much higher than my expertise and my abilities actually. Most of the Wigner is dealing with this theory. They are particle physicists. This nano stuff where you went is something else, is a different sub-institute. Okay, where I am. Okay, so we have pairs, triplets, and I have beautiful drawings of coordinate systems. Definition: two vectors are equal and only equal if their origin-centered representations are the same. What does it mean? You have a vector. You can give vectors in coordinates. Here everything is in Cartesian system, but they could be also in polar system. And also, this polar is good because the axes are straight. You could have curved coordinate system. For example, on the surface of the Earth, you could have a special coordinate system on the surface of a curved stuff like a sphere, or on the Earth. You know the inner angles, the sum of the inner angles of a triangle is not 180 degree. Do you know that? Okay, you know that. So it's a special stuff. So if you have a vector given with triplets or pairs or anything, and the components are equal, then the two vectors are equal. Okay, the magnitude of the vector is very simple. You take the components and it's okay. Do I have? No, I don't have. Oh, wait. It says pointer. There is no pointer. Doesn't matter. Okay. So you take the components, do this operation, and you get the length of the vector. There are two different things. One is the vector, it's an abstract object, and one is the coordinate represented. Wait. Oh, what's this?
It's from
It's a pointer. But I cannot move it. Why? Oh. Doesn't matter. Okay. Okay, I gave a deduction. Doesn't matter. If there is a vector, it could be a null vector. It means all components are zero. It's omnidirection. It has no direction actually. Special vector. Okay. If you have two vectors, you can add them. In a graphical way, you just do this stuff. You parallelly shift to the same starting point the vectors, form this parallelogram, and then the main diagonal is the sum of the two vectors. With components, you just add the components. Is it familiar? You have seen this. Okay. Do you know what is... did you ever use indexes? I mean, do you know what is epsilon I G K?
yes, the grade code.
Okay, who taught you this?
We first talked about it in the general chemistry course,
General chemistry.
and then in analytical chemistry last semester.
And do you know what is delta?
Yes.
IG. You know? I think not. That's great. Do you know how to do the vectorial product of two vectors using this epsilon?
Maybe we did that in the first last year. I don't remember. I have to.
Yeah, it was in the first semester.
Okay.
Yeah, with the previous lecture.
Okay. Just this is what I thought I will show you tomorrow. Okay. Multiplication of vectors with scalar. You could have three type of production with vectors when you product a vector with a scalar. Then it means you have a vector with the same direction, and but the length is scalar times the length of the vector. With components, you just multiply all components with it. That's simple. It was okay. It was very, very interesting. In the Hungarians didn't learn this in the secondary school. I learned it, but in the meantime it changed, and there were problems from this. Okay, subtraction of vectors. You have two vectors with components. Then it's very simple. A vector minus b vector. You just do this subtraction in the components. Graphically, you put the a and b vector to the same point, starting point, and then the a minus b is that vector that I should add to the b to get the a. That's it that I draw. It's very funny. So my daughters are in the primary school, and this is the same definition. How you give the definition of this minus between two scalars? It's the same. Same for vectors. Did you learn group theory? Do you know what is group? It's an algebraic stuff. Not in algebraic, it's an algebraic. Group.
I don't think so.
No problem. It's okay. It's perhaps it's an MSc level knowledge. You have elements, and you have an operation, and this operation on the elements never produce new elements, and the operation should be, I think, distributive. For example, if you have this, and you say the operation is rotation with 90 degree in this axis, then you have four elements. This. Doesn't matter, not important. Okay. This multiplication of vector with a scalar, and the difference of vectors has some rules. It's commutative, so the order could be changed. Associative, so you can put the bracket wherever you want. There is a null vector, and there is an inverse vector. That's minus vector.
What is the purpose of a null vector? Or I guess
Null vector?
Yes, I don't understand it. Would it just be like a point, or how does it have not any direction or magnitude? Or?
It's mathematics.
Yeah.
If you have an a vector and the b vector and the b or the a vector, and you, for example, okay, that's one. You have an a vector and the b vector is minus a vector. You add them together, then the result is a null vector. If you have an a vector and you multiply an a vector from itself, then also the result is this zero vector. When you have numbers, you have scalars. You must have unity, You must have 0. You must have invert scalar, that's minus vector, and you must have the same. That's why I talked about algebra and asked about groups. Okay? It is much easier to teach you. You are 4, and maximum you will be 5. I have direct feedback. Last year I have 130 students in the cubic in this other building, and you were 60. Actually, where are the others?
Computer science students are drivers.
Sorry?
The others are computer science students. I guess they have a different course.
So only you two are
Chemists. Yeah.
chemists in English.
In first year, yes. Chemists in English.
You will have a very special private education then. That's great, actually. Great. Or 4, or and what is your number? What is the number of your class?
Just us two in second year, yes.
So you have a laboratory after this class for 2.
Mm-hmm.
Actually, that's great. That's great.
Sometimes we share it with the Hungarian students though, so
Yeah,
sometimes,
we also share our labs with Hungarian students.
Mm.
so sometimes.
But it's like the students will be told that like 5. this
Yes, there's
semester.
not many of them as well.
Mm. Well, the purpose changed, so not everyone is a researcher who studies physics and chemistry. They also became later teacher, but only a few people studies teaching and everything because the salary is not so good in Hungary for teachers. Opposite to Finland, there the salary is high and the education level is quite high. They say that's the best. I have some comments on it, but doesn't matter. Okay, let's progress. Did I answer properly for your question?
I think so, yes.
Okay. Okay. Multiplication with scalar of a vector. There are 2 scalars, and you can put the bracket wherever you want. That's okay. And also it's called associativity, and the distributivity is you have 1 scalar and 2 vectors, a sum of vectors, and then you can do this operation. I did the deduction actually. It was not originally in the group. Tomorrow afternoon I will teach mathematics teachers. Well, that will be interesting. Okay, and there is another distributivity. If you have a sum of scalar and you multiply it with a vector, then you can use this operation. I mean this formula. Yes, and the last, if you have this unity vector, then it means you got no, it's not unity vector, it's unity. If you multiply the a vector with 1, you got the same vector. I think this is rappel, this is just repeat. That's why I don't tell you again everything. The unit vector, that's something that's useful. Very often you need the direction of something. Only the direction. And then you use this unit vector. Here, actually this is a coordinate system. Here this, I think I have a, no, I don't have. No, I don't have. start somehow. Ow. When I teach, I don't need manicure. You have three vectors, and this forms a coordinate system. I wrote here, I draw here the same. You have one vector, and with coordinates and then you can write everything with this. What was not mentioned? Here, these are segments. Very good. But it should not be a segment on a sphere. It's not a segment, it's a curve. And sometimes it's good if you have a coordinate system which is like okay, the simplest, if you have a coordinate system that's an ellipsoid, but it also could be something like this. It's hyperboloid, and no, it's visible. This should be a paraboloid. So it's paraboloid from here and the plane from here. When you do physics, then the calculations are sometimes very, very difficult. But if you choose an appropriate coordinate system, then it's not so difficult. For example, if there is a child and he's sitting in a chair and throw a ball, and the car is moving, then it's very difficult if you to describe and fix the equations and describe the movement of the ball if you are standing outside of the car, the moving car. But if you are inside of the moving car, you choose the appropriate reference frame, then it's much easier. That's why we have so many coordinate systems. For example, this was not part of the course last year, because why? So the IT students don't need this knowledge. Yeah, actually this is quite horrible. I mean, can you see what is on this board? This is much better. Okay, so we have unit vectors, and from the unit vectors we can build up any vectors. Which is good? The normal vector. You have a vector, you calculate the length of the vector, and then you get a vector which has unit length and the direction is the same. Okay, yes, this is also something. in 3 dimension, no, 2 dimension, you can give the equation of line. That's okay. You remember. You also, in 3 dimension, you can give the equation of a plane, which is very substantial, is the normal vector. In my job, in space physics, very often I have to determine the direction of a plane or a curved surface, and this direction is this normal vector. I will show you examples, and this is it. It's the same. Okay. If you this bisecting point, you have 2 vectors and actually 2 points. You draw vectors to the points, and then applying this formula, you got where is the bisecting point of this. You can use this formula, or with the drawings, you almost do the vector addition, but then you use the other diagonal, the smaller diagonal, and then you got in the intersection point of the diagonals, you got the bisecting point. Okay. If you want to determine the distance of 2 points, you draw vectors and then calculate the difference, and the difference vector's length is the distance of the 2 points. For example, I work with a spacecraft called Cluster. It's a European Space Agency built it, and there is something else. It's more appropriate is the multi-stage mountospheric mission. That's the NASA's product. It's also for spacecraft. If I want to determine the distance between them, then I draw from the middle of the Earth 1 point to one spacecraft and the next one, and then calculate the difference, and I got the length. Is it understandable? I will show you this. Okay, 2 points. That's okay. Yes. Equation of sphere. Are you familiar with this? There are more actually. If you can also use ellipsoid formula, then it's more difficult, and also hyperboloids. That's great. Actually, this is the same. You have 1 point, this R0, that's the center, and then there is other point that's moving, and the difference gives the sphere. The circle in 2 dimension, and sphere in 3 dimension. What is it in 4 dimension? A sphere in 4 dimension.
Time?
No, it's called hypersphere. Do you know what is hypercube? Hypersphere.
Yeah, I've heard about it, but I don't understand what it is.
In long time ago, 30 years ago, when I attended the secondary school, I started to programming in Turbo Pascal. That is Python right now. Actually, Python is much better than Turbo Pascal was. And then I understand what is the hypercube and the hypersphere. You cannot imagine it, but its protection is a kind of torus. Isten. Még van 5 percem. De szerintem 35 percem van, mert két... Önök kicsodák, önök tanítanak? Jó, egy 5 percre szabad összeterem. Jó? They want to repair something. Okay. The zero dimension, the cube is just a point. One dimension, just a segment. Two dimension, it's a square. A cube in three dimension. And then in 4 dimension, it's very difficult to draw. In 4 dimension, it's
Well, it can be drawn just like a cube inside of a cube.
yes. This is what I want to do. Yes, you are right.
Like it's a cube and a cube and a cube near.
Yeah. It's
and
okay.
they transform into each other. I saw the animation like 2D projection or 3D projection or 4D cube rotation.
Absurd.
Actually, this is what I never could do it, but with some linear algebra stuff I can do it right now, but I had no time to do it. So this is the projection to 3 dimension actually of this. If you have a light, then you got something like this in, doesn't matter. Okay, I should stop because we will run out of time. And for circle, and in 4 dimension, it's something it's a torus, should be, but I cannot draw it properly. And there are 3 actually, and it's moving. Okay, doesn't matter. Let me tell you if it is disturbing. Because, okay, so 2 minutes. Multiplication of vectors. Oh. Okay, so some students came to exam, and I really not break the neck of the students, but they didn't know what is vector, the definition at the end of January, and they mixed the scalar multiplication, scalar product and vector product of vectors. Some of them they consider the vector product as the addition, because you know the x is like the plus. Doesn't matter. So it was a horrible stuff. This is the scalar multiplication. It's very useful. For example, you can calculate the work from the force and from the movement. It also have some features like commutativity, distributivity for scalars and each other. With components, this is what you can do with the scalar multiplication. And because if you use the two definition, with the components and with the original definition, you can determine the angle of two vectors. Actually, this is something general in that you can do. If two vectors are perpendicular or orthogonal, then the scalar product is 0. Okay, projection doesn't matter. Vector product, that's more difficult. You have an A vector, you have a B vector, and then the A cross B is this. And it has a description that's how you rotate, but this is it. It's the length of this vector is the length of A and B times the angle of between the vectors. It is, be careful, it's anticommutative, so A cross B is minus B cross E. There is homogeneity, then if you calculate, if you multiply one vector with a scalar, then you can move the scalar before the cross product. Yes, and it's dissociative, so if you have a sum of two vectors and you do the vectorial product, then you can use this formula, so you can separate this. Okay, if you have a and B vector and these are parallel, then the vector real product is 0. Okay, with components, this is the formula. It's easy to prove, but I will show you something else tomorrow. And there is something else, the triplet or triple product. It's ABC. You do the vectorial product of A cross B, then scalar product C. There is this equations for this, and this is the volume of a parallelepipedon. And also, it's a good method if you have three vectors to calculate the triple product. And if it's 0, then they are in the same plan. If it's not 0, they are not in the same plan. Okay, so sorry, it's plus 3 minutes after I late a lot. I don't promise not late again, but it will be a bit less next time. Was anything new in this that I told you right now? For you not, because I use the same slides. For you, anything new? Okay, and can you apply this? Can you use this in vectors, addition, scalar, and so on? Yes, I think so, actually. Okay, thank you very much then, and see you tomorrow, and have a nice labor, or what do you have right now?
Yeah, analytical lab.
Okay. Thank you very much.